Hi students, I am Professor Sebastian Paul. In this lecture, we are discussing the example number 2 for the Boolean function simplification using a 3-variable K-map for POS expressions. So my dear students, in the lecture number 83, we had discussed the reduction rules for POS using K-map. So those rules include pair reduction, chord reduction, octet reduction, map rolling reduction, overlapping group and redundant group reductions. So my dear students, kindly go through this lecture number 83 for detailing of these different rules. And in the last lecture we had discussed an example for POS reduction 3-variable using K-map. So my dear student, in this lecture we are considering our second example. Our question is, simplify the following Boolean function using a 3-variable map. Our function is a plus b plus c into a plus b plus c dash into a plus b dash plus c into a plus b dash plus c dash into a dash plus b dash plus c. So if we are analyzing this given function, we can see three different variables. Those variables are a, b and c, and each of this individual term has all these three variables. So the given function has three variables. That variable set include a, b and c, and next step what we have to do is represent these three variables in the max term representation. For this, what we have to do is convert these variables into its max term. That is, a plus b plus c can be represented in max term representation as 0 0 0. That is, a variable is represented as binary 0 and a variable complement is represented as 1 in the max term representation. That is, a plus b plus c is 0 0 0. 0 0 1 means a plus b plus c dash. A plus b dash plus c can be represented as 0 1 0. A plus b dash plus c dash can be represented as 0 1 1. A dash plus b dash plus c can be represented as 1 1 0. This 0 0 0 is equivalent to M0. 0 0 1 is equivalent to M1, 0 1 0 is equivalent to M3, 0 1 1 is equivalent to M4, and 1 1 0 is equivalent to M6. That is, the given function f of a, b, c is equivalent to M0 dot, M1 dot, M3 dot, M4 dot, M6, or simply pi of 0 1 3 4 6. So the given function is represented in max term representation as pi of 0 1 3 4 6. And since this question deals with a 3-variable, we should consider the K-map with a 2 raised to 3 different cells. That is 8 cell. That is a 3-variable K-map. And this 3-variable K-map, the rows represent the variable a and the column represents the variable b and c. So our given function includes pi of 0 1 3 4 6. Thus, we should mark the value 0 on the cells 0, 1, 3, 4 and 6, and the remaining cells, that is cell number 2, 5 and 7, are marked with the value 1. So this is the first step, and in the second step we should consider the different pairs in this K-map. Firstly, we are pairing the cells 0 and 1, and this pair is marked with blue color. And secondly, we can pair the cells 1 and 3, and which is marked with red color. And thirdly, we can mark the cells 4 and 6 by applying the map rolling reduction rule for pairing. So we are pairing the cells 4 and 6. These cells lies in the leftmost column and the rightmost column. By applying the map rolling reduction rule, we can pair this. In the next step, what we have to do is reduce these pairs by applying the different rules. Our rules is simple. We should consider the variables which are unchanged, and we should ignore the variable with values are changing. So if we are considering the first pair, the pair marked in blue color, the pair consists of cells with 0 and 1, and this pair lies in the first row and it lies in the column number 1 and column number 2. Since it is lying in the first row, the value of a remains unchanged with a value is equal to 0, and the value of b is also unchanged with 0 in both these cells, and the value of C is changing from 0 to 1 if we are moving from column 1 to column 2. So here the value of B is marked in red and value of C is marked in blue color. We can see that the value of B is 0 in both these cells and value of C is changing from 0 to 1 in these cells. So the reduced pair will be A equal to 0 and B is equal to 0. That is, the reduction of the first pair is equivalent to A plus B. If we are considering the second pair, which is marked in the red color, this pair also lies in the first row and this pair lies in the column number 2 and column number 3. And since this pair lying in the first row, the value of A remains unchanged, thus we can take A is equal to 0. And the value of C is unchanging in this pair. So the value of C is equal to 1 in both these cells, but the value of B is 0 in the second column and the value of B is 1 in the third column. Thus we can ignore the value of B and we should take the value of C. And here for reduction we can see that the A value is 0 and the B value is 1. Thus the reduction of the second pair is equal to A plus C dash. Since we are dealing with A is equal to 0, we can take A, and since we are dealing with C is equal to 1, we should consider C dash. Thus the reduced pair is A plus C dash. And similarly the third pair lies in the row number 2 and it lies in the column 1 and column number 4. Since the value of A is unchanged with A is equal to 1, we can consider A complement into the final reduction. And if we are considering the column 1 and column 4, the value of B is 0 in the first column and the value of B is 1 in the last column. Thus we can ignore the value of B since the value of B is changing, and the value of C remains 0 in both these columns, and we should consider the value of C into the final reduced pair. Thus the reduction of the third pair will be A complement plus C. Thus we got the reduction of all the pairs. The first pair is A plus B, second pair is A plus C complement, and the third pair is A complement plus C. And the final reduced POS is ANDing of all these individual terms. That is, POS is equal to A plus B dot A plus C complement dot A complement plus C. So this will be the final reduction of this given function. So my dear students, our given function was A plus B plus C into A plus B plus C complement into A plus B complement plus C into A plus B complement plus C complement into A complement plus B complement plus C, which we had represented as pi of 0.1346, and the reduction or the POS for this given function is A plus B into A plus C complement into A complement plus C. So my dear students, hope you had understood this topic. So dear students, kindly go through this assignment question. Our question is, simplify the Boolean function f of x, y, z is equivalent to pi of 0, 2, 4, 6 using a 3-variable K-map. So my dear students, in the upcoming lecture we are discussing the last example for a 3-variable K-map solution for POS. So dear students, see you soon. Until then, goodbye, thank you, and all the best.